Twin engines are highly prized for their safety margins and long-range strike missions.
Twin engines are not just more power, but more options when missions go wrong. Twin-engine jets often carry larger systems and redundancy built into the airframe.
Many twin-engine fighters are designed for stability under heavy loads and high-speed maneuvering.
Two engines can generate the thrust needed for heavier fuel and weapons while keeping takeoff performance strong.
Long missions start on the ground, planning for distance, weather, and return margins.
Robust structures often pair with twin-engine layouts for high gross weight and hard use.
Twin engines can provide strong acceleration, valuable for heavy takeoffs and hot conditions. Engine redundancy becomes a safety story when operating far from alternate airfields.
More thrust can translate into better climb performance and margin under load.
Twin engines can sustain flight even if one engine degrades, an advantage for survivability and recovery.
Sounding. Long-range missions often demand high-altitude efficiency and stable power generation for sensors.
Twin-engine fighters frequently carry more avionics and cooling capacity.
Range and payload often grow together in twin-engine strike-focused designs.
Overwater operations highlight why redundancy matters. Few places to land, harsh consequences for failure.
Twin engines provide extra electrical and hydraulic power for long-duration sensor use and complex systems.
Remote geography reduces diversion options, making reliability and redundancy more than a comfort.
Many twin-engine fighters use twin tails for control authority at high angles and during heavy load flight.
Redundancy can extend beyond engines to generators, pumps, and flight-critical systems.
Bad weather and icing risk demand performance margin and robust systems management.
Long-range strike can be extended by refueling, but internal range still sets the baseline.
Aerodynamic efficiency matters, but engines supply the energy budget for everything the jet does.
Twin-engine aircraft can be configured for multi-role missions: air defense, escort, and strike.
Long-range strike is about reach, projecting power to distant targets while maintaining a safe return plan.
Twin engines also mean more maintenance touchpoints and more logistics behind the scenes.
The trade-off for redundancy is cost, parts, hours, and specialized support.
Twin engines are a strategic choice. More thrust for heavy loads and more safety margin when operating far from home.
Large radar, electronic warfare, and communications suites often demand significant onboard power.
On long-range missions, awareness is paramount. Speed is secondary to the data collected by these sensors. Endurance is a weapon. Being there longer expands options and pressure.
Heat and density altitude can punish performance, so extra thrust margin becomes valuable.
Twin-engine fighters can maintain strong thrust at altitude for efficient cruise and rapid repositioning. Long-range operations often reveal themselves in the sky, driving stealth and routing considerations. With their extended range, twin-engine fighters provide crucial escort capabilities, protecting strike packages across vast distances.
Coordinated missions rely on communications resilience and shared situational awareness.
Fatigue management becomes part of mission safety on long sorties.
Stable handling supports precision navigation and safer recovery in bad conditions.
For long-range strike, weather is a battlefield variable. Visibility, turbulence, and alternate plans.
Night operations inherently increase the risk. This makes reliability and redundancy far more valuable.
Long-range sorties end the way they began, with safe recovery as the true measure of success.
Twin engines can reduce catastrophic single-point failure risk, but require deeper inspection cycles.
Readiness depends on logistics, spares, trained technicians, and consistent procedures.
Twin-engine fleets often cost more per flight hour, but may justify it with mission set and geography.
Survivability includes basing, dispersed shelters, rapid turnaround, and protected infrastructure.
Twin-engine fighters are often used for demanding quick-reaction missions, requiring strong acceleration and climb.
The intake shock cones and splitter plates are crucial high-speed designs, carefully managing airflow to protect the engines across diverse flight regimes.
Long-range strike often demands teamwork across platforms.
Some twin-engine fighters are favored for carrier operations due to payload and recovery margins.
Naval environments punish machinery, salt, wind, and violent deck cycles.
Overwater safety. Overwater safety is where twin-engine redundancy feels most tangible.
A long-range strike can be launched from shifting bases, turning geography into strategy.
Long missions truly test concentration, system health, and fuel discipline.
Twin engines can increase survivability and mission confidence when operating at distance, at night, or over water, where a single failure can become a crisis.
Recovery, landing safely with reserves, defines true mission success.
Heavy aircraft benefit from strong power and stability during approach and go-around contingencies.
Structural robustness complements twin-engine philosophy. Survive the hard day, fly tomorrow.
Turnaround time is a strategic resource. Maintenance teams decide how fast air power regenerates.
Two engines also mean more inspections: blades, temperatures, vibration, and wear.
Listen. Procurement is always a compromise between cost, risk, and mission needs.
Nations choose twin-engine fighters when geography, threat, or mission set demands maximum margin.
Long-range strike often depends on finding targets, navigating threats, and coordinating timing, not just speed.
Modern fighters fight with information, jamming resistance, deception, and situational clarity.
Extreme cold and remote basing push reliability requirements higher.
Austere runways and harsh climates make maintenance and power margins essential.
Twin-engine fighters often support longer radii with heavier loads, depending on design and doctrine.
Extra thrust can translate into flexibility, climb, dash, or reposition without sacrificing return margins. Strike missions are about carrying capability, but also about managing drag, fuel, and safe recovery. That safe return is a design goal. Redundancy helps, but training and procedures finish the job.
Sustainability is the hidden battlefield. Engines require parts pipelines, diagnostics, and skilled labor.
Twin engines can increase availability challenges if support systems are weak. All-weather readiness is part of deterrence, showing capability anytime.
Twin-engine power can support heavier sensor suites and long-range awareness tools. Geography often decides fleet choices. Large oceans and long borders favor higher safety margin designs. While twin engines reduce risks associated with distance, threat, and weather, they introduce new challenges, increasing both cost and complexity.
The human is still the center of the system. Technology supports judgment, not replaces it.
Twin-engine fighters are built for the full spectrum of demanding sorties.
Safety advantages are most visible when things go wrong, but they're earned every day through engineering and support.
The real cost of capability is maintenance discipline and constant readiness work.
Long-range strike is ultimately about controlled reach. Arrive, execute, and return safely.
Twin-engine fighters endure because they offer power with margin, supporting long-range strike missions, complex systems,